we just like estimate some of these angles since they're close to the...
Okay, let's look at 15 here and how to solve that one. With 15a, we should be at 0.53. So if we come out 5 from here, 1, 2, 3, 4, 5, 1, 2, 3. All right, so right here is where we want to end up. Okay, we want to end up right there. Now we've got to then calculate the length of this vector. How far away did this resultant vector end? Okay. So how would we figure that out? How do we do the length of a resultant vector? The resultant vector is equal to the square root of the horizontal component squared plus the vertical component squared. So in this case, we have 5 squared plus 3 squared, right? And that would be the square root of 25 plus 9. So the square root of 36. Is that right? Is that what y'all were doing?
Yes.
Okay. On that one.
Which should be 6.
Which should be 6, right?
Yeah, different. Although I still got the same answer.
My way is wrong.
My way is correct. My way.
Oh, 34. Sorry, not 36, 34. Thank you. Yeah. See if I can do my math this morning. I was trying to make it too easy. Because that would be 6. This is 5 point something.
5.8.
5.83. Thank you. That helps.
Oh, my way. I still got 5.8. My way was
All right,
wrong,
there you
but
go.
I still got it.
Now, once the absolute value, so if that came out negative, we would make it positive. 5.83. Ah, I'm having troubles writing today. Try if I... Thinking and writing. It's early in the morning. There we go. I'm glad y'all are paying attention. All right, so the angle that we'd figure out here, we'd have to use the other equation, which is what? Theta equals... What was the other equation we wrote down last class period? Not just tangent.
Tangent negative 1 v of y over v.
The inverse tangent, yep. Okay, tangent to negative. The inverse tangent of what?
V of y over v of x.
Okay, the vertical component over the horizontal component there. So then to figure out this angle, we need to take the inverse tangent of, and the y component they gave us was 3. So we'll plug in 3. And the x component they gave us was 5. So 3/5 or 0.2. So the 0.6, sorry. 3/5 would be 0.6. 1/5 is 0.2. 2/5 would be 0.4. 3/5 would be 0.6. So the inverse tangent of 0.6. And what angle is that? Okay, so it's got 31 degrees. So we would okay. We would measure that from the positive x-axis. Now, I think your directions here are a little confusing when doing the angle. It says note the direction is measured in degrees counterclockwise from the x-axis. It should be, yeah, that should be correct. So we're gonna go counterclockwise, 31 degrees right there.
Oh, okay. Shush. You shush.
So make sure that you go that 31 degrees from that point. Now, so let's do the next one, the next part of this. And you could leave that up there as A. So that's all drawn in there. And so there we have A. Now let's draw in B. 9, negative 2. So 9, 4, 5, 6, 7, 8, 9, negative 2. Okay, and this is easier to do if you have a straight edge. So there we have B. Did I draw that in? Did I draw that in there correctly? Hopefully, right? Then you would have to figure out B. And as we do that, we're not actually really worried about the negative values because they become positive when we do this. 9 squared would give us 81, 2 squared, negative 2 squared would give us 4, right? So this should be the square root of 85. And when you do the square root of 85, what do we come up with? 9 point something, right?
9.22.
Okay. So 9.22. And then we would want to do the angle for this also. Now, this is where I think those top directions are confusing. Where it says counterclockwise from the positive x-axis. We're just actually going to have to figure out what this angle is right here from the positive x-axis. Okay. What is that one? What is that angle there? Okay. So we want to do the inverse tangent of the y component over the x component. And what does that give us? Well, that should give you negative 12.5 degrees, of course. Okay, and I'll write this back in up here. All right, so keep working on the rest of those.